In this video, we're going to learn how to solve problems involving solubility product constants. Alright, so we learn how to find the KSP or solubility product constant of a reaction. Okay, now let's begin with this problem or question. Okay, so let's look at this question. It says, analysis of saturated solution of silver carbonate shows that the concentration of the carbonate in the saturated solution was this value. Calculate the solubility product constant of silver carbonate. Alright, now note that the solubility product constant of a reaction is equal to the product of the molar concentration or solubility of the ions involved in the equilibrium, each raised to the power of the stoichiometric coefficient in the balanced chemical equation. Now, so basically what it means for this question, this is going to be the decomposition reaction. Alright, so silver carbonate we decompose, so this is an equilibrium reaction as well. Right, so we decompose to give 2 moles of silver ion, alright, plus 1 mole of carbonate ion. Alright, now if we check this, we're going to have the mole ratio to be 1:2:1. Alright, so therefore the solubility product constant now be equal to the ions raised to the power of the stoichiometric coefficient. So it's going to be this ion, silver ion. So the stoichiometric coefficient here is 2 raised to 2, alright, times the carbonate ion. The stoichiometric coefficient is 1. Alright, so let's multiply the molar concentration of solubility of these ions raised to its power of stoichiometric coefficient. So when you do it, you're going to have, I hope this place will enter me. Alright, so let's manage this down below. So it's going to be, for silver ion, it's going to be, the molar concentration there is 1.27 times 10 to the power minus 4, alright, in brackets. So raised to the power 2, alright, times, then for the carbonate ion is still 1.27 times 10 to the power minus 4. Alright, so let me punch this with my calculator. Wait, before we punch the calculator, we have to multiply the silver ion molar concentration by 2. Because of the mole ratio here is 2, so we have to multiply the silver ion molar concentration by 2. Alright, very important. Yeah, multiply it by 2 and also raise it to each stoichiometric coefficient 2. Alright, so let's now point the calculator and get the final answer. Okay, so the solubility product constant KSP will be, when you multiply it, will be 3.22, alright, 58 times 10 to the power minus 8. So this will be the answer. It does not have a unit. Alright, so let's wipe this and solve another problem. Okay, let's look at this problem. It said 150 ml of saturated solution of calcium fluoride was analyzed and found to contain this value of calcium fluoride. Calculate the solubility product constant at 25 degrees Celsius for calcium fluoride. Alright, so this is the decomposition reaction, calcium fluoride. Alright, we decompose. Remember, is in equilibrium as well. So calcium fluoride we decompose to give these ions, calcium ion, alright, plus 2 moles of fluorine ion. Therefore, the solubility product constant will be the product of the molar concentration of solubility of these ions involved. Alright, so it's going to be calcium ion, the product of this molar concentration times that of fluorine. Alright, so fluorine is going to be this raised to the stoichiometric coefficient. The stoichiometric coefficient of calcium ion is 1, that of fluorine is 2, so raised to the power 2. Alright, yeah, if you put the values now, KSP will be, so note again that the mole ratio here is, we have 1 is to 2. Alright, so it's going to be, when you input the values, the molar concentration of calcium ion from the equation is going to be 4.08 times 10 to the power minus 3. Alright, multiply 2 times, because of this mole ratio 2, so you multiply by 2, you multiply that of fluorine ion by 2 because the mole ratio is 2, and even the mole ratio of calcium is also 2, would have multiplied the molar concentration by 2 as well. So 2 times the molar concentration of fluorine is still 4.08 times 10 to the power minus 3. Alright, raised to each stoichiometric coefficient. So let's multiply everything together. It's going to give us the solubility polar constant for this reaction. Alright, so it's going to give us, when we multiply to 2.716, if you are leaving it to 3 decimal places here, alright, times 10 raised to the power minus 7. That will be the solubility polar constant. Does not have a unit. Alright, so let's write this and solve one more problem on this before we call it a class. Okay, so let's look at this problem. It says analysis of a saturated solution of lead-2 iodide show that 25 degrees Celsius, that 0.250 dm cube of the solution contains 0.141 gram lead-2 iodide. Calculate the solubility product constant for lead-2 iodide. So we are given the molar mass of lead-2 iodide to be this. So firstly, we're going to have the decomposition reaction to be lead-2 iodide will decompose to give, alright, lead-2 ion, alright, plus 2 moles of iodine ion. Alright, so this is going to be, the KSP will be the product of the lead-2 and that's of iodine raised to their power of stoichiometric coefficient. So it will be lead-2 ion times that of iodine ion raised to the stoichiometric coefficient. So that of lead here is 1, that of iodine here is 2. Alright, now in this question we don't have the molar concentration. We are given the molar mass and the mass of lead-2 iodide. So in chemistry, to calculate the number of moles of a reaction, is the formula will be is mass over molar mass. To get number of moles, give you moles. Alright, so for this particular reaction, going to be mass of lead-2 iodide. Here we have it to be 0.141. Alright, this is 1 over the molar mass is 461. So let me point this with my calculator. So it's going to give us 3.058. If I leave it in the 2 decimal places here, times 10 to the power minus 4 mole. Alright, so now that you have gotten the mole value, to now get the molar concentration to get it is concentration will now be this mole, this value of mole over the volume in this question. So when you put the value, you're going to have 3.05 times, okay, 3.058. Let me clean this. Alright, 8 times 10 to the power minus 4 all over. So the volume in this question, we have it to 0.250 dm cube. That's 0.250. Alright, So let me point use my calculator and get it. Alright, so when you divide through, you're going to have 1.22 if you're leaving in two decimal places here, right, times 10 to the power minus 3. Alright, so this will be the value for the molar concentration. Now that we've gotten it, let's use it and solve for this solubility product constant. So as usual, it's going to be, so you multiply the ions, the molar concentration of these ions raised to their power of the chemical coefficient. Okay, so it's going to be for lead ion, it's going to be in bracket 1.22 times 10 to the power minus 3, alright, times the iodine ion. Remember, this iodine is having mole ratio. They have a mole ratio of 1:1:2. Alright, so the mole ratio times the molar concentration of iodine, which is also 1.22 times 10 to the power minus 3. Alright, this is minus 3. Then the chemical coefficient of iodine is 2. Alright, so let me write this minus 3 very well. Let me clean it. Okay, so we have minus 3 here. Now, let me multiply through with my calculator here, and that will be the solubility product constant for this reaction. Okay, so it's going to give 7.26 if you are leaving in two decimal places here, times 10 to the power minus 9. Alright, so this will be the solubility product constant for this reaction. And with this, we have come to the end of the class. Hope you learned something interesting. This is basically how you can solve problems involving solubility product constant, how you can find solubility product constant in chemistry. You just make use of this equation and you can use it and find the solubility product constant of a reaction. That's for this time, guys. Thanks for watching. Don't forget to subscribe if you are new to the channel for more videos. So like, share, and comment on the video. Tell me how you feel from what you have learned. If you seem to have any specific questions to ask, feel free to leave your question in the comment section below and I'll try to give you a response. That's it for this time, guys. Thanks for watching.